Hello. So can you hear me well?
Yes, madam.
All right,
Dengar je.
great. Okay, so let's start the lecture today. So I will share my screen. Okay, so last week we have gone through the triple integrals by using the Cartesian coordinate. So today we are going to deal with the triple integrals by using the cylindrical coordinate. Cylindrical coordinate. Okay, so in this section you are going to use the cylindrical coordinate. So we'll be dealing with the r, okay, the theta, and also the z. Yeah. Okay, so before we learn about how to solve for the volume using cylindrical coordinate, okay, so first thing is I want you to look at the example 2.23. There is page 81 that is to convert, okay, from Cartesian coordinate to cylindrical coordinate. Okay, so you can refer to page 81, okay, of your module, example um, 2.23, yeah, 2.23, okay. So in this example, you have to convert, okay, or change to cylindrical coordinate. Then only you evaluate the triple integrals. You evaluate the triple integrals. Okay, so we go to the first questions. That is the questions A. So this is the questions. Okay, so they will have a triple integrals. This 4 minus y square. Okay, and 16 minus x square minus y square and square root. Okay, you have a z at the center. This is not about volume yet. So this is about solving the triple integrals. So you have a dz, okay, dx, and also the dy. Okay, so when you have to solve using the cylindrical coordinate, means that you don't want to see the x, y, z anymore. Okay, so all the x, y, z in the triple integral, you have to convert it into the r, okay, theta, and also the z. Okay, so here you need to apply the formulation of conversion that you have learned earlier, okay, which is x equals to r cos theta, right? And y equals to r sine theta. And the z remain the same, okay? Because in the cylindrical coordinate, you have coordinate z as well. Okay, so the z remain, okay? So the angle of your theta will be ranging from 0, okay, your theta, to 2 pi, okay? This is 360, yeah. Okay, so we start to convert it. Okay, first of all, we look at the dz interval, okay, the dz interval. So according to the interval, it says that the dz is from 0 until 16 minus x square minus y square. Okay, right here. All right. Okay, so this is the interval. Okay, so for this dz, okay, we can convert it. Okay, meaning that we don't want to see the xy anymore, so we can convert it directly. Okay, so we will convert it, okay, by using the formula. Oh yeah, I think I missed one formula over here. We still have the x square plus y square equals to r square. So these are the relationship between the x, the y, the r, and also the theta. So we can convert directly. So 16 minus, okay, x square plus y square. So I'm going to put it here as the r square, okay, because when I factor out the negative, I take it outside. So this one will become positive already, yeah. Okay, so that's why it become 16 minus r square. Okay, 16 minus r square. So this one will be your dz interval for the cylindrical coordinate. Next, we move on to the ds interval. Okay, so this is a ds interval. Okay, so the ds interval is from 0 to 4 minus y square. Okay, 4 minus y square. So for this one, if you want to convert it into something related to r and theta, you need to draw it out. Okay, you need to draw it out. Okay, so just like what we have learned previously. So here is telling us that the x is equals to 0, okay, and the x is equals to 4 minus y square. Okay, 4 minus y square. So x equals to 0 is the straight line, okay, located at the position x equals to 0 lah. But for this one, okay, you need to draw it out. Okay, so when you draw it out, you just modify the equations. So here will become x squared equals to 4 minus y squared. This is because I square the right side and left side. Okay, so when you move it and rearrange it, you'll find that actually it is equation for a circle. Yeah, this is the equation for a circle. Okay, circle, and this circle has a radius of 2. 2 because 2 square will equals to 4. 2 square equals to 4. Okay, so you draw a circle. Okay, draw a circle. Draw a circle first. Okay, draw a circle first. Draw a circle. So you label it as y. This is x. And the radius, you know, is 2. You draw a circle. So we go back again and look at our interval. Our interval is telling us that the ds is from 0. Okay, the x is from 0 until the equations of a circle. So first of all, okay, we draw what is x equals to 0. Okay, x equals to 0 will be this line. Okay, I think you see the red line. Okay, this is at the position that x is equals to 0. Equals to 0. Okay, and then from x equals to 0, you move to the equations of the circle. So the equation of the circle is this one. Okay, so you see this is the equation of the circle. I go to the circle. Okay, so basically it refers to this region. Okay, so you shade this region first. Not yet complete, not yet complete. You shade this region. Okay, so the dx is telling you x from 0 until the equations of a circle. That's why I shade these portions. Right, now we look at our last interval. Our last interval, okay, that is the dy. The y is from 0 to 2. Y is from 0 to 2. Okay, so I write here the dy is from 0 to 2. Okay, meaning that the y is 0. Okay, to y is equals to 2. Okay, so y is 0. When y is 0, it refers to this horizontal line. Y is 0. This is y is equal to 0. Because the 0 is here. Okay, the 0 is here. Okay, y equals to 2. 2 is this point. Okay, because the radius is also 2, right? So in fact, you will make a line here. Okay, you will make a line. Okay, this one. Okay, make a line. So the region that is referred by this interval, okay, should be the whole part here. Okay, should be the whole part here. So after you consider, okay, the ds and also the dy, you will pick this region. Okay, you will pick this region, okay, because this is the overlapping region, and that fulfill the dx and also the dy. Okay, you pick these yellow regions. Okay, so when you look at these yellow regions, okay, this yellow region actually just refer to the first quadrants, okay, of this circle. And now you have to define the r, okay, you have to define the dr and also the d theta, because it is cylindrical coordinate system. Okay, so you need to have the r and also the theta. So where is r? R is the radius. Okay, so this is a portion of a circle. So the radius will be from 0 to 2. Okay, 0 to 2. You see 0 to 2, right? 0 to 2. So you write down 0 to 2. And you just want to refer to the region, the yellow region. Okay, so from here up to here, the angle is 90 degrees. So it will be 0 up to pi over 2, 90 degree. Okay, so you have defined the interval for the dr, d theta, and just now we have the dz over here. Okay, now we put them back to our questions. Okay, initially it was in the Cartesian coordinate, and now you're going to convert it into dz. Okay, r, dr, and dk, because you need to solve by using the cylindrical coordinate. So we write it out again. So for the triple integrals, okay, you have the r, dr, and d theta. Okay, just now at the center it is z, right? So you can just remain the z, okay? Because the z is part of the cylindrical coordinate. So the dz will be from 0 up to 16 minus r squared and square root. Okay? And then for the dr, you take 0 to 2. For the theta, you take 0 to pi over 2. Okay? Pi over 2. So you can start to solve these questions. Okay, so this one, okay, you see here you have a variable. So you cannot press calculator. You have to solve it manually. Okay, you have to solve manually. So how to solve manually? 0 to z, when you integrate, it becomes z squared over 2. And you can insert your interval here. Okay, so you still have the r. Okay. So when you replace the z with 16 minus r squared, okay, it will become 16 minus r squared over 2, right? Because this here you have a square, and this is a square root, right? So it becomes no more square root anymore. Okay, so you have an r here. Okay, you have an r here, and dr, d theta. Okay, so this step is easy now. Okay, why? Because you can press calculator. So everybody, you can press calculator. You can press calculator. So let's try 16 minus x squared, okay, in your calculator. Minus x squared over 2, then multiply with the x, 2 and 0. Okay, we get 14, huh? Get 14. And d theta. Okay, and the last step is just multiply 14 with the pi over 2. Okay, so you will get 7 pi. Okay, so the answer is just 7 pi because it's nothing related to the volume. Okay, so this is how you convert from triple integral that is written using the Cartesian coordinate. You convert it into the cylindrical coordinate. Okay, cylindrical coordinate. Right, okay. Alright, can follow. We move on to the next example. Okay, that is the example in exercise 2F behind. This one is the example. Okay, this is the example in the module. Okay, of course, there you can try the next example in your module. But here I want to try exercise 2F behind. Okay, the exercise behind. Page 86. Page 86, we try the question 2A. Try the question 2A. Okay, very similar to the previous questions. You have to change to cylindrical coordinate and evaluate. Okay, so now I write down the triple integral. Okay, negative 4 minus x squared 4 minus x squared. Okay. 0, 4 minus x squared minus y squared. And this is 4x squared. dz, dy, and dx. Don't copy the wrong questions, okay? Okay. So now you need to convert it into the cylindrical coordinate, okay? Meaning dz r, dr, d theta. Okay. So we go through again the step that I explained just now. We look at the first one, that is the dz. Okay, this is the dz. Okay, so this is the dz. So the dz interval, you can convert it directly. Okay, so you can just write it down. 0 up to 4 minus r squared. Okay, so this one I just write it directly. Okay, because it's very easy. Okay, but this part you can convert it into the r squared. Okay, and next we move on to the dy. Okay, so these are the dy interval. Dy interval. So one is negative. Okay, the other is positive. Okay, so in fact they refer to the same functions. Meaning that the y is equals to square root 4 minus x squared. Okay, so this is a function that you need to draw. Okay, you need to draw. So before you draw, you need to identify what is the radius of this circle. So it is y squared. Okay, and you move the x to the left side. So you see again. Okay, same circle. Okay, circle with the radius of 2. Radius of 2. Okay, so now you need to draw the circle. Draw a circle. Okay, draw a circle. The y, the x. Okay, this is a circle. So thus this circle has a radius of 2. Okay, so this is the radius of the circle. Okay, let's see again. What is the interval for the y? Okay, the saying that the y, okay, is from the negative part of the circle until the positive part of the circle. Right? Okay, negative part and positive part of the circle. Okay, so you refer basically the dy is telling you the whole circle, right? Because it's from the negative. This is the negative of the circle. And to move on to the positive of the circle. Okay, that's why it means for the whole circle. Okay, whole circle. We look at the last interval. Okay, that is our dx. Okay, our dx here. So this is the interval for our dx from negative 2 to 2. Okay, so our dx, is from negative 2 to 2. Okay, so this is our x. 2 is here, so negative 2 will be here. Right, so you make a line. Okay, you make a line. This is the negative 2 and positive 2. Line is not straight enough. Okay. This. Okay. So x from negative 2 to 2. Okay. It means that now negative 2 to 2. Negative 2 to 2 here. Okay. Again, you refer to the same parts. Okay. Circles. Okay. So now when you want to define the dr and d theta, you will refer to the whole circles. Okay. So you could write down your dr. Okay. It's from 0 to 2. Okay, 0 to 2, 0 to 2, right? 0 to 2. All the point will be from center until the 2. Okay. Okay. All the point 0 to 2. And d theta, okay, if you refer to the whole circles, also the angle will be 2 pi. Right. Angle will be 2 pi. Now you can put it into your triple integral. Right, so it is 0 to 4 minus r squared. Right. Okay, at the middle you have the 4x squared. 4x squared. Okay, middle you have a 4x squared. So here you have a dz, r, dr, and d theta. So r is from 0 to 2, 0 to 2 pi. Okay, 0 to 2, 0 to 2 pi. Okay, so the next step, of course lah, you have to convert this thing. Okay, you don't want to see the x because you want to solve using the r and theta. Okay, so x, you're going to change it to the r cos theta. R cos theta, So this one is going to change to four. Be careful the square. Okay, you have to make sure r cos theta. Okay, all the terms they are square. Okay, so dz, r, dr, and d theta. Right. Okay, so the first integral is with respect to the dz. So when you expect this term, it doesn't have the z. Okay, so it will be easy. You just top out, right? So just top out a z. So it is 4r squared cos. Okay, and top up with the 4 minus r squared. Right. Okay, this is because you integrate the dz, you get a z. Okay, and you have the r and dr and d theta. Okay, now you have to integrate with respect to the r. Okay, but I think you can see here is a cos theta. Okay, so cos theta in this case will be a constant, so you can take it out if you want to press using the calculator, right? So the cos square theta, you take it out as a constant, so you just focus. Okay, so this one you can combine, become 4r cubed. Okay, 4 minus r squared. Okay, okay, so this part now you can press calculator. You can press calculator. So you get 64 over 3, yeah? 64 over 3. Right. Okay, d theta. Okay. Right, so now you can press calculator, okay, for this cos square theta. But when you press this thing, be careful on the square, how you want to define the square. Okay, so in calculator, you should define this way, cos theta and then square, like this, You don't put a square here, then you'll be wrong, okay? So put like this, okay? So cos square square 2 pi 0. Okay, you get 64 over 3 pi. All right. Okay, can you get this thing? Is that okay, everyone?
Okay.
Okay. Okay, I move on to the next question, which is to find the volume. This is about conversions. We can try this question tomorrow. Okay, so we go to the question number 3. Maybe number 3A. Okay, we put 3A. Okay, right. Same exercise. Exercise 2F. Exercise 2F. Right, so you have a question 3A. This is page 86 also. Okay, so using the cylindrical coordinate to find the volume of the solid enclosed by paraboloid. Okay, enclosed by paraboloid. So they already tell is a paraboloid, and the equation is z equals to x squared plus y squared. Okay, and also the plane z equal to 16. Z equals to 16. Okay, so how to draw this paraboloid? Okay, so you don't need to actually assume many level curve. Okay, you know the shape of the paraboloid already, but you want to know whether it is in this shape or upside down, right? Okay, so how you will do it? How you will do it? You will find its values. Okay, when the position z is 0, right? Okay, the position z is 0. Okay, so we take the equations. Z equals to x squared plus y squared. Okay, we want to know whether it's this type or this type. Okay, we look at this position. This is the position z equals to 0. So when you replace the z with 0, okay, so basically you will see it is 0. Means that the circles has a radius of 0, meaning that it's a point. Okay, so your paraboloid will be in this shape. Okay, will be in this shape. It's not this one. Okay, will not be this one. Okay, so you can roughly sketch your paraboloid. So you can sketch this thing. This is a paraboloid. Yeah, red color. That's okay. Just continue. Paraboloid. Okay. Enclosed by a paraboloid, meaning that it's within the paraboloid, inside the paraboloid. And it says that the z equals to 16. So in fact, the paraboloid you can actually extend out. This thing you can extend up to infinity. This thing you can extend up to infinity. Okay, the z can be infinity, but they want you to stop at the plane z equals to 16, meaning that you are going to cut this thing. You are going to cut this thing, maybe to cut this thing at a position. Okay, z equals to 16. You cut. This is the plane z equals to 16. You cut it horizontally. You cut it. Okay, so these top portions you don't want to know. You don't want to know is volume. Okay, you are just interested on the portion below the plane z equals to 16, which is this one, because you cut it. Okay, now you want to find the volume. Okay, find the volume. Are you clear about this structure? Okay, right? Not too difficult. Just cut it horizontally. Okay, so this is the equation for volume. If you want to solve using the cylindrical coordinate system. Okay, so meaning that you need to define the z, you need to define the r, and also the theta. Okay, so how to define the dz? Okay, so when you want to define the dz, you have to put yourself inside. Imagine you are sitting inside. Imagine when you're sitting inside. Okay, when you look down, basically you can see this part. Am I right? Okay, you can see this paraboloid. The base is covered by the paraboloid. Okay, so we will say that the dz will be from the paraboloid. Okay, that is the x squared plus y squared. Okay, this is the equation of paraboloid. Until when you look up. Okay, when you look up, you see this plane, right? This is a horizontal plane. It has a fixed value, okay, which is equals to 16. So I will write down 16 here. Okay. Next, we move on to this part. Okay, the dr and d theta. This one usually you have to choose projections because just now we already defined the dz, right? So you have to view the whole structure, the yellow structure, from the top. Okay, you view it from the top. So when you view it from the top, you can see a circle, right? You can see a circle. This is a circle that you will see when you look from the top. Okay, this circle refer to this one, eh? Oh. Okay, it refer to this one, eh? Refer to this circle you are looking at. Okay, so see these circles here. So what's the radius of this circle? Any idea? How to find the radius of this circle? Okay, this circle is located at the position z equals to 16. Am I right? Z equals to 16. Okay, so you take this 16 and put it in the equation of the paraboloid. Okay, put it in the equation of paraboloid. So it becomes 16 equals to x squared plus y squared. Okay, x squared plus y squared. So obviously you can see that your radius is equals to 4. Okay, 4. It's not 16, it's 4. Okay, so from there you can now define your dr to be from 0 to 4, and d theta will be from 0 to 2 pi. Why 2 pi? Because it's a complete circle. You really see a circles from the top. Okay. Now you have to replace them here. Okay. Before you replace, okay, because we want to solve using the cylindrical coordinate, right? So this part you should replace it with the r square. Okay. So now I put the r square here, and I put the 16, 0, 4, okay, 0, 2 pi. Yeah. Okay. Okay. So now we solve for the volume. 0 to pi, 0 to 4. Okay, here is equals to 1. So when you integrate the dz, it becomes 16 minus r squared. Okay, 16 minus r squared. r dr and d theta. Okay, right. Okay, so continue. Okay, press calculator. 16 minus r squared. Okay, 4 and 0. So you get 64 here. Right, 64 pi d theta. So you get 128 pi. And this is unit cube because it's the volume. Any questions so far?
Madam,
Yeah.
DZ ni mana?
Yes?
DZ ni mana, Madam?
DZ. Okay, I just simplify DZ ni. Okay, so for this DZ, right? Yeah, I will explain to you. So this DZ mana? Alright. So this DZ, when you integrate it, yeah, because it's DZ, right? It will become Z. Okay, so when you put your interval here, r squared at 16, right? So 16 will be here, r squared will be here. So it becomes 16 minus r squared. Okay, so this is what appears here. Okay. Okay?
Okay, Madam. Faham.
Yeah, okay. Thank you for asking. Right. Any more questions? Any more questions? No, Alright. So let's try one more questions for the volume. Okay. We try the question 3B. Okay, 3B. Same exercise, 3B. Okay. Again, you have to use a cylindrical coordinate to find the volume of the solid inside cylinder. So I will write that inside cylinder. I say inside cylinder. So this is the equation of the cylinder. Okay, inside cylinder. Between. Okay, in between two planes. Okay, between two planes. That is between the plane Z equals to 2 and x plus Z equals to 8. Okay. Okay, so let's draw it out first. First, we draw the cylinder. It didn't specify us the cylinder, right? Okay, so we just draw a cylinder. Draw a cylinder. Okay. So everybody, okay, we draw cylinders. So I draw a cylinder. I think they're singing already. So draw the cylinder. Then draw a cylinder. Then now draw the axis. Okay, I'm drawing this way because I want to tell you that this cylinder actually can extend to negative z-axis. Okay, you can extend it in the negative part and the positive part. Okay, then this is the z, this is the y, and this is the x. Okay, so maybe you need one more. Okay, so you can see the things. Okay, so this cylinder has a radius of 5. Okay, this is 5. Okay, so between plane Z equals to 2, okay, Z equals to 2 is a horizontal plane, might be here. Okay, you cut this cylinder horizontally, okay, at the position Z equals to 2. Okay, so maybe you have one more. Okay, one more this thing. Okay, you cut it. Okay, you use this plane to cut this thing. Cut it, cut this thing. Okay, and x plus z equals to 8. Okay, x plus z equals to 8. Okay, let's see. Let's block this one. Okay, let's draw this one. Maybe you cannot draw in 3D first. Okay, but we draw in 2D. Okay, if we want to draw in 2D means that it is 8 minus the x. It's a straight line. So we can draw 2D. Right. So positive 8 is here. Okay, so negative, it will be in these directions. Okay, something like this. This is the z, this is the x. So what is the coordinate of this point? This is when the z equals to 0. So the x is equals to 8. Okay, equals to 8. Okay, so now you want to combine this cylinder with the plane. Okay, so position z equals to 8 might be somewhere here. Right. This is 5. 8 might be here. Just for an example. Okay, so you connect it. Oops. How come like this? This one. You cut like this. You cut your cylinder. And you can draw in a plane shape. If you want to draw in a plane shape, it's okay. Okay. But if you want to reflect the cylinders in the 2D diagram, it will be something like this. Because the cylinder has a radius of 5, right? Okay, so if you put it here, 5 is here, 5 is here. Okay, the height is just until 2, right? Oh, the height is from 2. Sorry, so I'll draw here better. 2. Okay. This is I draw a cylinder in 2D. This is a side view, 2D view. 2. Okay. Like this. 2 is here. So you slice it. Between the plane z equals to 2 and also the x plus z equals to 8. Can you imagine this one? Or you want to use GeoGebra? You use GeoGebra. Okay, insert the x squared plus y squared equals to 25. Okay, so automatically you will see a cylinder. Okay, z equals to 2. Z equals to 2. Okay, see, you cut the cylinder. Inside cylinder and between the plane. Okay, between the plane. So you have the x plus z equals to 8. Yeah. Can you see the portion that you actually want to find? Okay. This is a 2D graph that I'm going to sketch. Oh yeah. So I think I have to extend out, right? Then only you can view. Okay. Alright. This one is extend. So meaning I should erase this one. Don't erase first. Okay, I don't erase first. Huh? So this is how the plane actually slices the cylinder. This is a side view. Side view. 2D view. 2D. And this is 3D. That's why you see how come the cylinder in 3D is in circular shape, but this is a rectangular shape, but because it's a side view. Okay, so you can see this plane slice the cylinder, and you have one more plane here. Okay, that is the z equals to 2. This plane, z equals to 2. This one, right? Slice the cylinder. Okay. So you have to find the volume of the solid inside the cylinder between the plane. Okay, so obviously it will be this part. You need to find its volume, am I right? Okay, this part, if you look at the GeoGebra, right, between the plane. Okay, so you need to find the volume. Okay, you see, can you see this thing? Are you able to see this thing?
Can.
Can Okay. So maybe I will draw a 3D view for you. This is then you have I draw without the axis, so you can view the structure. Just want you to view the structure. Okay. Can you see these cylinders were sliced by the plane? Okay, this is the plane. Z equals to 2. Okay, then you slice the cylinder using x plus z equals to 8. Okay, so the shape will be like this. So now you find the volume. Find the volumes. Find the volumes. Okay, so it is using triple integrals. Here will be 1. It will be dz, r, dr, and d theta, because you're going to solve using the cylindrical, right? Okay. So now the first is the dz. Define the interval of the dz. So remember I told you when you find the interval for the dz, you have to assume yourself is sitting inside. Okay, you are inside this 3D graph. You are inside this cylinder. Okay, you are inside this cylinder. Okay, so when you look up, okay, you can see this slanted surface, right? Because it is cut by this. Okay, it is cut by this surface where the equation is 8 minus x. Okay, so it is 8 minus x here. Okay, right, because it's at the top, right? So when you refer down, okay, you see a horizontal surface. It's a flat horizontal surface at a position z equals to 2. Okay, so you get this interval, right? Okay, for the r, dr, d theta, so you have to view these structures from the top. Okay, from the top. So basically, you can see these circular structures here, right? This is the circles that you will see if you view from the top. You see the circles, Okay. So this circle, same as the radius of the cylinder, right? So you can straight away define the r because you know the radius of the cylinder is from 0 to 5, right? Okay, 0 to 5. Why it is 5? It is here, right? 5. Okay. And it's a complete circles. So d theta 0 to 2 pi. Okay. So you put in here 8 minus x 0 to 5 0 to 2 pi. Okay, done. Okay, so you have defined all the interval. Now what you have to do is to solve it. Okay, 0 2 pi 0 5. Okay, so this one, like I explained before, okay, the middle is 1, so you will have a z inside and then you replace with the values. Okay, so I will be straightforward. It will become 8 minus x minus 2. Okay, r dr d theta. Okay, so here you can simplify to 6, 6 minus x. So you can press calculator. 6 minus x, 6 minus x. So is equals to 35 over 2 d theta. Oh, right. Sorry. I think I make a wrong mistake. Because I haven't convert, right? I haven't convert. Sorry. This one I have to convert. Yes. And because I want to solve by using the cylindrical, right? So it can't be x, but you have to convert r cos theta. So let me erase it. This one. Okay. R cos theta. Alright, I'm sorry. Okay, so this is the 8 minus r cos theta minus 2, minus 2. Okay, minus 2. Okay, so it will be 6. Okay, 6 minus r cos theta. Right, you have an r here. Okay, so you can multiply the r inside. Okay, you can multiply the r inside because if you want to press calculator, you have to split it. Okay, dr. Py is p. So now you press calculator, you have to press by part. Okay, 6r first. Okay, 6r first. So you integrate 0 to 5, 6r. 5 and 0. So for this part, you get 75, right? Minus, okay. Now you take out this cos theta. So you integrate the r squared from 0 to 5. So you get 125 over 3. Okay, so just to be clear, this one is you press this 6r dr. Okay, you get 75, and this one is you press 0 to 5 r squared dr. Okay, you take out the cos. So now you can press the whole in the equations. Two pi and 0. So it is 150. Is that okay for you? Yeah.
Okay, madam.
All right. Thank you. Okay, so we move on to the next one. We move on to the next one. This is a triple integral in spherical coordinate. Okay. Okay, move on to the next one. Triple integral. In spherical coordinate. Okay, so spherical coordinate, basically you have a rho, you have a phi, and you have a theta. Okay, and if you want to use the triple spherical coordinate to find the volume, okay, the equation will be like this. You will have the triple integrals. Here at the middle, it is still 1, okay, but you have to multiply with the rho square, sine phi, d rho, d phi, and d theta, okay, just as what is written in your module. Okay, this one will be a set of equation to represent the dv, okay, for spherical coordinate. Okay, it will be a set, okay, it will be always there. These two terms will be always there. Okay, and for the spherical coordinate, there are conversions that you need to remember also. Okay, like what you have shown in your first test, right? As rho multiply equal by theta, yes, sine phi, okay, y equals to rho sine theta sine phi, and z, the z equals to rho cos phi. Okay, so these are the equations, and also if you have a x square plus y square plus z square is equals to the rho square. Okay, rho square. So do you remember where is the angle theta and where is the angle phi? You can look at your module. Okay, if this is a sphere, okay, you must understand where is all this angle. We have a cylinder like this. Okay, so rho will be the radius of the circle, right? Okay, so this is the radius of the circle, rho. Okay, and the phi will be the angle from the z-axis. This is the z-axis, so phi will be the angle from the z-axis going downwards, okay, until the negative z. Okay, so this is the phi. And for the theta, okay, theta angle will be same like the cylindrical coordinate. If you view from the top, okay, so the theta will be from z-axis, x-axis, like this. Okay, so this one will be a theta. Okay, will be a theta. Okay, so this one is represented the circles over here. Okay, the theta. Okay. All right, so let's look at one example. Example 2. Let me see. Example 2.30. Okay. The first exercise in your module. Example 2.30. Sorry, 30. Page 88. Okay, page 88. Sketch the solid bounded above by a sphere. Okay, means that now you have a solid. Okay, so the top of the solid is covered by a sphere. So that sphere has a radius of 3, okay, and below by a cone. Below is a cone. Cone is a cone. Cone, the shape of a cone is like this, right? The cone. Okay, this is the cone. Okay, with the phi equals to pi over 3. Okay, pi over 3. Okay, below by a cone, as well as its projection on the xy plane. Okay, so sketch. So you need to sketch this thing. So sketch the sphere first. Let's sketch a sphere. So you sketch a sphere. Okay, then you sketch the axis. Okay, this is a sphere. Okay, and then you have a cone. Let's sketch the cone. Cone. Okay, sketch the cone. Okay. So the solid bounded above. See, this is the meaning. Bounded above by a sphere. Okay. Okay. And also below by the cone. Below by the cone. Okay, so it refer to these regions. Okay, this region. You need to find the volumes, okay, using the spherical coordinate. Okay, so what's the equations for the volumes? This is question B, B. By using spherical coordinate, find the volume of a solid in part A. You have to draw this thing. Okay, so now you need to find the volumes. Okay, using these equations. Rho square, sine phi, d rho, d phi, and d theta. Okay, you need to define the interval. Okay, what is rho? Okay, so I already explained to you. Rho is the radius. Okay, it's the radius of the sphere. So this radius, this sphere has a radius of from 0 until 3. Okay, because it's mentioned by the questions. Rho is 3. Okay, so d rho, the d rho will be from 0 to 3. 0 to 3, yeah. And for the d phi, and d phi will be the angle that is from the z-axis going down. So if you look at these portions, right, the red portions, okay, so your phi will be the angles over here. Okay, and the question already said that the phi is pi over 3. Okay, 0 until pi over 3. And the d theta will be the angles if you view from top. Okay, so when you view from top, you will see this circle, right? You see this circle.
2 pi.
Yes? Alright, Ken? Okay. Okay, so this circle has a radius of, it has angle of 0 to 2 pi. Okay, so the way of defining the interval in the spherical coordinate is slightly different compared to the Cartesians and also the cylindrical. Okay, you need to view this thing, okay, in terms of angle. Okay, phi is in angle, theta is in angle, and this one is radius. Okay, the radius of the sphere. So you can put them now inside the equations. Okay, so the theta is from 0 to 2 pi. Okay, phi is from 0 to pi over 3. Okay, and the rho is from 0 to 3. Okay, so this thing remain. So d rho, d phi, and d theta. Okay, so for the first integrations, you are dealing with the rho. So the sine phi, okay, you can take it out. Okay, you can take it out. So the sine phi, you take it out. Okay, so you just integrate 0 to 3, rho square, d rho, okay, d phi, and d theta. So now you press calculator this part. Okay, you can press calculator this part. Integrate square, 3, and 0. Okay, so this part will give you 9. 9. And this is sine phi, right? So I write down the sine phi. Okay, the next term we are going to integrate the phi. 0 pi over 3, 0 to pi. Okay, now you press calculator again for the second term. Oops. So the second terms, that is with respect to the phi. Okay. Okay, so integrate 9 sine phi okay, so you get 9 over 2 d theta. 9 over 2 d theta. And the last one will be easy. You get 9 pi. Okay, just multiply. So this one will be the volume of the solid that you calculate using the spherical coordinate system. Okay, spherical coordinate systems. Is that okay?
Okay, madam.
Okay.
Okay.
Okay, good. Okay. Now, we go to the next example. Okay, I want to explain to you the next example. That is example 2.23. Okay, 2.23 of your module. Example, right? Example 2.23. That is a page 89. Okay, so we look at the example A. Example A. So by using suitable coordinate, find the volume of the solid bounded above by sphere. Okay, above by sphere. So you know that it's a sphere. Okay, so this sphere has the equation x squared plus y squared plus z squared equals to 2z. Okay, so this is the equation of circle, so the sphere. Below by cone. It's quite similar to the previous one, right? Okay, below by cone, below. Below by cone. Okay, z equals to square root x squared plus y squared. Okay, just now the question is telling you what is the rho and what is the phi. But this question, they don't tell you. They just tell you what is the shape, what is the equations. So you have to find the rho, you have to find the phi yourself. And always I like to write down this thing. Above by what? Below by what? Okay, so you have to write this one so you know that which region you should choose. Which region you want to find its volume. So it's very important, okay? You must be aware of all these wordings, above and below. So we draw this thing, okay? So we look at the sphere first. So this sphere is slightly different compared to the sphere that we draw usually, because usually at the right hand side we will have the radius, right? But this one is 2z. So meaning that this radius, this equation, this function, you have to modify or rewrite a bit, okay, before you're able to draw the sphere. Okay, so let's look at how we can rewrite this thing. Okay, so because here got the z, because you see here you have a z, so you have to move the z to the left side. and keep the right side as 0. Okay, and here you have to apply the rules of completing the square, right? Completing the square. So these two things, okay, you can remain. For this one, you have to modify it to be z minus 1 square. Okay, z minus 1 square. Okay,
Madam,
yes,
mana tu Z-nya?
2z. This 2z. Yeah, oh, sorry. This is 2z, huh? Okay, 2z, sorry. 2z, It's not z, It's 2z, Okay, so you have to rewrite it to be z minus 1. Okay, this is completing the square. So when you rewrite it to z minus 1, in fact, this z minus 1 is equals to z squared minus 2z plus 1. Okay, so these two things, okay, is already included, but this one is not included. Okay, when you write your function in this way, you have introduced one more plus 1 over here. Okay, so in order to remove the plus 1, you have to write minus 1 over here. Okay, minus 1 over here. And this part remain the same. Okay, in fact, you can actually prove it. Okay, because just now I said when you expand it, you get this thing, right? You get this thing. Okay, if you top up with minus 1, so this part will gone. And just left this part, which is the same as this one. Okay, so you must have this minus 1. You cannot change the question, you cannot change the function, but you can just modify the way of writing it. Okay, the way of writing it. Okay, so this negative 1, when you move it to the right side, it will become positive 1. So you have a x squared plus y squared plus z minus 1 square equals to 1. Okay, now you can see the function for the circle, for the sphere already. Okay, but this sphere, its center is not at 0, 0, 0, but the center is at 0, 0, and 1. Plus 1, Okay, I write down 1. Okay, and the radius is equals to 1. Rho is equals to 1. Okay, so now you can draw your circle. So not circle, sorry, sphere. Okay, so you can draw a sphere now. So for the sphere, because the center is at 0, 0, 1, so it means that you have to shift it up. You have to shift it up. And because the radius is equals to 1, so you will find that it is in this shape. Okay. So the radius refer to this one, the rho. This is the rho of a sphere, equals to 1. Okay, right. So this is a circle. Next, we have one more term, right? So above is covered by the sphere, below by the cone. Okay, so we draw the cone like usual. We draw the cone like usual. Okay, so the cone. Okay, you can draw. You can just bring it the cone like this. Okay, you can draw the cone like this. This is cone. Okay, so top of the solid is bounded by the sphere. Okay, by the sphere. This one, the top of it is bounded by the sphere, and below by the cone. Okay, so you see this solid now. Okay, so it refer to this part. So now, what will be the volume? Okay, So you have to use a formula, right? So when you want to use a formula, means that you need to define the rho, you need to define the phi, and also you need to define the theta. Okay, so let's see how to define the rho. Okay, how to define the rho. Because this rho is slightly different compared to the previous one. Because the center is at the 0, 0, 1. Okay, the previous one, the center is at the 0, 0, 0. So the rho is a fixed value. But for this one, the rho is not a fixed value. Okay, so if you check the rho, okay, from here until here, the reading will be different from here until here. It will be different. Okay, so this is the rho. Okay, this is the rho if following the coordinate systems. If following the coordinate system. Just now the rho here is represent the rho of the sphere. Okay, so just want to avoid confusions. So the rho of the based on the coordinate system, okay, will be from the origin. Will be from the origins to all the point that is covered by the regions. Or here. Okay, so this is your rho. So your rho won't be a fixed value in this case. It will be equations. So how to find the equations of the rho? Okay, so you can find the equation of the rho by referring to the equation of the sphere. Okay, so you have your equation sphere equals to x squared plus y squared plus z squared equals to 2z. This is the equation of the sphere. So this whole thing, if you rewrite it into the spherical coordinate systems, you can rewrite it to be rho square, right? Rho square. And on the other hand, at the right side, okay, the z can be rewrite as the 2 multiply what? Okay, you can refer in front, and that is the rho cos phi. Okay, rho cos phi. So this is power 2, and you can cancel this one, left the power 1 over here, 2 cos phi. So meaning that now your rho is depend on the value of your phi. Am I right? Phi is the angles from the axis Z, okay, until here, phi. So for all these different points that I mentioned just now, okay, their rho will be depend on the phi. What is the phi? Different phi, different opening, you will have a different rho. That's why in this case, your rho is represented in equations. Okay, it is represented in equations. So you have complete this one, the first one, d rho. Okay, it will be from 0 until 2 cos phi. Represented in equations. Not fixed value. Not fixed value. Okay, now it's about the phi. Now you're going to define the d phi, right? So the d phi is depend on the opening of your cone. This is the phi. What is the phi of this cone? You know what is the equation of your cone, right? So the equation of your cone is equals to x squared plus y squared and square root. Now you have to convert all them into the spherical coordinate system in order to find your phi. Okay, so for the z, you convert it into the rho cos phi. Just now we did already. And for this x squared plus y squared, you have to refer which one? Okay, let us find it. Yeah, you have to refer this. Okay, these two equations. Okay. So x squared will be equals to rho sine phi and cos phi. Cos theta. Sorry, cos theta. This is square. To represent the x square. And for the y, it will be rho sine phi and sine theta. square, and then square root. Okay, and square root. So we simplify a term inside the square first. So you will have a raw square. Okay, you will have a sine square phi cos square theta, right? Plus the raw square. Yeah, here you have a sine square phi again. You have a sine square theta. Okay. Next, factor it out. Factor it out. So you have a raw square sine phi square. Okay, so these are the same thing. You take it out, and inside the bracket you will have cos square theta left, and also the sine square theta left. Very complicated, but I want to explain to you. This thing, once you know, you can always apply it. You don't need to derive it repeatedly. Okay? So this one, it will be equals to 1. Yeah, equals to 1. So now you left this thing. Okay? And also the square root. Okay? So this is easy because there is no plus, right? Okay? So you can write it to be rho and sine phi. Many of you cannot actually determine whether you can just remove the square and also the square root or not. Okay, for example, in this case, right, it is the rho square sine square phi. Okay, so I said that you can just remove the square and square root to make it this, right? But in different case, for example, rho square plus sine square phi square root. So can you remove it to be rho plus sine phi? The answer is no. Okay? So this thing is you cannot remove like this. But this one can. Can you see what's the difference? Here you don't have anything between the, this is multiply. You multiply. But this one is plus. It's plus. So you cannot remove the square and square root like this. This is wrong. Okay? So this is wrong. This is correct. Okay? When you multiply, you can do it. When you plus, you cannot do it. Okay? If you cannot remember this concept, okay, you can just assume you have a 4, okay, multiply with a 4. That's square root, huh? And on the other hand, you have 4 plus 4. This one will give you 4. Am I right? This one will give you 4. Huh? How about this one? This one will give you answer square root 8, right? Okay? So meaning that this one you can just remove the square and square root, but this one you cannot. Okay? If you use the concept, this one, this thing over here, meaning that it will be 2 plus 2. Yeah, because you remove the square, right? 2 plus 2 equals to 4. Okay? Which is not the same as square root 8. This is wrong. Okay, but for this one, it will become 2 multiplied 2, which is equals to 4, which is the same as this one. Okay, so many of you made this mistake in the test. Okay, you simply remove the square root. So end up you cannot get the correct shape of your ellipse. Okay, we go back to the questions over here. Right. Cos here. Stop here. Okay, so how to simplify this thing? This one you can divide with this one. Am I right? So you can move the cos to the right hand side. Okay. So you have a square, yeah, square root. Yeah. Okay. So here left 1. So you have the sine phi over cos phi. Okay. So sine phi over cos phi equals to tangent phi. So if you press calculator for this one, you can get your phi equals to pi over 4. Okay, which is 45 degrees. So meaning that when you have a cone and the equation is this one, okay, the phi is always pi over 4. Okay, so I repeat, when you have a cone and its equation is this one, the phi is always pi over 4. Okay, pi over 4, meaning that you don't need to repeat all this step anymore. Because I want you to know how you get this pi over 4. Okay, this is how you get the pi over 4. Okay, but in the following example, you don't need to do all this calculation anymore. Just use this one. Okay, so in this case, we'll continue back, because just now it's just showing you why it is pi over 4. Okay, our dv will be from 0 until pi over 4. Okay, you see, 0 is here. 0 is here. Okay, so your cone will open like this, right, until pi over 4. Okay, until pi over 4. Okay, so we have settled 2 of the interval. Okay, then we go to the last one, that is a theta, right? Theta is you view this structure from top. Okay, you view this structure from top, you will see a circle. Okay, you will see this circle right at the middle here. Yeah, this is a circle at the middle here. You will see this thing. You see this circle. Okay, so this circle has is a complete circle. Okay, when it is a complete circle, its d theta will be equal from 0 to 2 pi. Okay, 0 to 2 pi. Okay, so now you have get everything. Okay, you put them into equations. Okay, theta, which is from 0 to 2 pi. Right, 0 to 2 pi. And this one is from 0 to pi over 4. That is your rho. And your phi is from 0 until cos, no, rho cos theta, cos phi. Okay, cos phi. Okay, 2 cos phi. 2 cos phi. Okay, 2 cos phi. 2 cos phi. Okay, here is equals to 1 multiply. Okay, no need to write 1. Rho square sin phi d rho d phi and d theta. Okay, I think this part is okay for you. You can try. Okay, you can try it. The first one, you take out the sin phi. You take out the sin phi. Then you press calculator. Square 2. Oh, this one you have to do it manually. Yeah, you cannot press calculator. Sorry. So this one you will have a rho cube. Okay, because integrate. Yeah. 3 2 cos phi 0 d phi d theta. Okay, this one do it manually. So you have a sin theta, you write again. So this would be 2 power 3, right? And the cos also power 3 phi, right? Over 3, okay? You replace the value. Now, you can use calculator. Here comes the calculator. Sin phi multiply cos p power 3. Okay, and then 4 so we get 8/3. And the answer is wrong. Huh? Where is my mistake? 2 cos 0. Where did I make mistake? The answer is pi. Sin. Let me try again. Pi. Sin x multiply cos x 3 5/4 0 multiply 8/3. Oh yeah, I got this one wrong, huh? 1/2. Okay, so we get pi. Is that okay? Okay, so if okay, we move on to the next example. Page 91. This is about conversions. So the current one, we calculate the volume. Okay, the next one, we are going to look at how to convert from Cartesian to spherical coordinate. Okay, and solve the triple integrals. Okay, this is the example 2.33. Page 91. Okay, look at the question A. How to convert. So given this one, this is given by question 0, 9 minus x squared. Okay. Copy the question first. Okay. dz, dy, and dx. Okay. So this triple integral is given, okay, by using Cartesian coordinate system. Now you need to convert it into spherical. Okay, meaning this one you don't want to see anymore, but you want to see rho square sin phi d rho d phi and d theta. Okay, you want to replace them. Okay, so how to do it? So it is a bit different compared to the previous one for the cylindrical coordinate where you can just convert it, but here you cannot. You need to draw the structures. Okay, you need to draw the 3D structures based on the intervals given here. Okay, so these are your interval given. Okay, so you have to draw these 3D structures and define your new rho, okay, d rho, d phi, and d theta. Okay, let's do it. Okay, so the dz is telling you that it is from square root x squared plus y squared to, okay, 18 minus x squared minus y squared. So these two, they are actually representing two different solid, two different 3D graph. Okay, this one is telling you that it is a cone. Okay, and this one is telling you that it is actually a sphere. Okay, a sphere. You can actually rewrite it. Okay, because if you write in this way, you will know that it is a sphere. So you will have x squared plus y squared plus z squared equals to 18. Okay? So how to be from the cone to the sphere? If you remember how we derive, okay, for the volume, okay, previously, okay, maybe we refer to the cylindrical coordinate. We go to the cylindrical coordinate first. Yeah, this part. Okay, this one. When we have a 3D structures, I always ask you to look up and look down. Am I right? When you look up, you see what surface. When you look down, you see what kind of surface. So this is how the dz is derived. So same as the questions over here. Okay. So when you look up, you see a sphere. Okay. When you look up, you see a sphere. Okay? You see a sphere. When you look down, you see a cone. Okay? So this is your region. Okay, so we have drawn this thing first. Okay, we draw the solid first. Okay, so this is a sphere. Okay, draw a sphere first. Okay, and then you draw a cone. Cone overlap with the sphere. Okay, we draw a cone. Okay, this is a cone. Okay, this is your cone. Overlap the sphere with the cone. Okay, then go back again. Look at your dz. When you look down, okay, when you look down, you see the cone, right? You see the cone. When you look up, you see the sphere. So, meaning that you actually, the interval actually representing this region. Okay, representing these regions. So, after you draw this one, then only you define the d rho, d phi, and d theta. Okay? Right. So, this one is a dz. Dz. Not yet finished. Okay? You just complete the dz. You just review the dz, but you haven't reviewed the dy and dx. Okay. You look at your dy. Dy is from 0 to 9 minus x squared. Okay. So dy is from 0 until 9 minus x squared. Okay. So meaning that you have one function here, 9 minus x squared, square root. Okay, so y squared plus x squared equals to 9. It is a circle. Okay, it is a circle. So you draw again a circle. Okay, which region it means? You need to shade it. You need to shade the region. Okay, So y is here. Y is from 0 until the equations of the circle. 0 is here. Equation of the circle is here. Okay, so it represents the upper part of the circle. Okay, so this dy is telling me that it refers to the upper part of the circle. Okay, how about the dx? Dx is from -3 to 3. Okay, so this is a circle that has a radius of 3, yeah, right? So your dx is from -3 to 3. Meaning the whole. Okay, so you only consider the overlap region. Okay, that is this one, the overlap regions. Okay, so refer to this region only, yeah. Okay, it refer to this region only. So this is a solid we can imagine, the solid we can imagine, but in fact it does not cover the whole solid. It just cover half of it, because based on the dx dy, we know they just want half of it. Okay, now we define the d rho, okay, d theta and d phi. Okay, d rho. Rho represents the radius of the sphere. So it is always from this point until here, all the points over here. So all the points over here, they will have the same rho, okay, same radius, which is what? Anyone know what is the rho over here? Anyone know?
18.
18? Is that correct, 18? Okay. Almost correct already. But it's not 18. It is square root 18. Right. Square root 18, right? Because the equation is a square, right? So square root 18. So for the d phi, you settled the d rho already, yeah? We move on to d phi. Okay? For the d phi, d phi represent what? D phi represent the angle from here until here. How big your cone open? How big? So you look at the equation of your cone. Yeah, it's this equation. Okay? Just now we have find out what is the phi for this cone. If you remember, very, very long steps over here. Yeah, this one. Remember what I tell you all just now? When you have a cone, yes, in these equations, your phi will be always pi over 4. Okay? You don't need to write down all the steps anymore. You just use this. Okay, you just use this. Meaning that you will write down, my phi will be from 0 until pi over 4. Okay? And last one will be the d theta. D theta. Okay, so when I want to look for the interval for the theta, I will always look at 2D view, which is this one, 2D view. Okay, so what is theta? Theta is the angle from here until here. Am I right? So it is 180, meaning that it is from 0 until pi. 0 until pi. Alright, so you have settled all these three intervals. Now you can put them into your triple integrals. 0 to pi. This is the d theta. 0 to pi over 4. This is the phi. And 0 to square root 18. Right, this is the rho of the sphere. The rho of the sphere. And here, you have to replace it with rho square sine phi d rho d phi d theta. You must remember all these they must align with the interval. You must make sure they align. Okay, if you wrongly place it, then your answer will be wrong. Okay, so now you can solve like usual. 0 to pi, 0 pi over 4. Okay, so this one you can press calculator. Square bracket 0. So you get 25.46, something like this. 25.46. Okay, so this sine phi you can just remain here because it is a constant in this case. Phi. Next, we go to the second integral with respect to the phi. Okay, so you press your calculator sine phi, sine phi. Should be from pi over 4. Okay, so in this case, and multiply 25.46. So you get 7.46 d theta. Okay, so this one you can just multiply pi. So you get 23.43. Is it the same? So let me check. Is it the same? Okay, it's the same. Okay, same as the answer in the module. Right? So this is about conversions. Conversions. How you convert from Cartesian to spherical. Any questions? Then everybody is very confusing when you're dealing with the spherical. So usually students are very confused when they're dealing with the spherical. Okay, never mind. Tomorrow we will go through many more exercise. Okay, so you can try the exercise, then ask questions. Okay. So let me go through what we have learned today. Oh, my note is a bit messy. Okay. So we have go through how to perform the triple integral using cylindrical coordinate. Okay. First is how to convert. Okay. Let's say if you have been given the Cartesian coordinate, okay, how you convert into the cylindrical coordinate. Okay, so for the dz is easy. Okay, you can just convert directly because for both cylindrical and Cartesians, they have a dz, they have a z, so you can just convert directly. Next, when moving to the dx dy, you need to draw it out. Okay, you need to draw it out, and after you draw it out, you identify which region is actually mentioned by the questions, and then you define your own dr and d theta. Okay, so this is about the conversions. Then we use it to find the volumes. Okay, I think this is not that difficult for the volume. So when you want to calculate for the volume, you must draw it out. Okay, draw it out and read the questions. Okay, what is above, what is below. Okay, and then when you want to define a dz using the cylindrical, you need to assume you are inside the solid. When you look up and when you look down, okay, what you can see, what surface you can see. Okay, so from there you define your dz. And in terms of the dr d theta, you still have to view your 3D structures from top. Means it's the xy projections. Okay, so from there you define the dr and also the d theta. Okay, so when you deal with the solid that is a combinations of many planes or many 3D graph, okay, you need to view the solid from different directions, so that you can imagine properly. As long as you know what is at the top, what is at the bottom, okay, what is the view when you refer to the XY projections, okay, then you should be able to define the dz, dr, and d theta. Okay. Next is about the triple integrals in spherical coordinate. Okay, this is much more complicated because you're dealing with the d rho, d phi, and d theta, and especially when you want to convert it, the equation is also much more complex compared to the others. Okay, the first thing you must know is what is rho, what is phi, and what is theta in the spherical coordinate system. What are them? Okay, because it is very important. Okay, so for the direct questions, okay, when you have been given the rho, given the phi, okay, you can do the calculation very easy. But if it didn't give you anything, but just gives you the solid, you have to read the questions. What is above? What is below? Draw the 3D structures out. Okay, identify, okay, which part you want to find is volume. Okay, which part you want to find is volumes. And if you found that your structure is a shifted sphere, for example, like in this example, it is a shifted sphere. Okay, so your rho, you have to define yourself, okay, which is this one. This is the way you find your rho. And for the phi, okay, for the phi, okay, as I mentioned many times, okay, if the equation of your chord is this one, z equals to square root x squared plus y squared, your phi is always pi over 4. Okay, this is something you must remember. You must remember. Okay, and then next one is about conversions. From the xyz, convert into rho, phi, d theta. How to convert? So you have to draw the structures based on the dz, dy, and dx. Draw the structures. Identify what are your interested region. Okay, and then you define your rho, your phi, and d theta. Okay, are you all still there?
Doctor,
Yes.
can you share this slide at Doctor?
Share apa ini?
Yeah, yes, Doctor.
Yeah, yes. I will always share the handout. Okay, in the author, you can always refer to the author.
Alright, Doctor.
Okay, so tomorrow, our tutorial section is still, online because I'm not feeling that well. So, let's try our best to understand the tutorial and exercise that we're going to try tomorrow. And actually, I need you to ask questions. I know that you all have a lot of questions, especially for the sphericals. So please ask the questions tomorrow, or if you want to step back and ask questions also, okay? All right. So if you don't have any question, remember to mark your attendance in the author. Okay? I won't reopen again. So just mark your attendance right after the class. Okay? So I will see you tomorrow. Thank you, class.
Thank you, madam.
Thank you,
Okay.
madam.
Thank you, Doctor.
Bye, doctor.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Thank you.
Doctor.
Bye-bye.
Have a nice day, doctor.
Thank you.
Thank you, doctor.
Bye-bye. If you have question, you can stay and ask me. No problem.
Thank you, Doctor.
Welcome. Bye-bye. Any more question from the others? Are you still in front of your laptop or handphone? Okay.